Ever find yourself staring at the night sky, wondering if we're alone in this vast universe? Imagine a scenario where not just one, but multiple advanced civilizations have constructed gigantic structures around their stars, capturing their energy.
A group of researchers say they've identified at least 7 alien megastructures known as Dyson spheres.
That potential superior intelligent life might be creating buildings or devices.
There's a new study that may suggest we are not alone.
Alien megastructures.
Dyson spheres, what?
And this could be the biggest story of the past 500 years.
It sounds like science fiction, right? Let's dive into the world of Dyson spheres, those incredible theoretical structures that could wrap around an entire star, and find out. Number 1. Dyson sphere. Proposed by physicist Freeman Dyson in the 1960s, the idea involves super-advanced civilizations building huge structures around their stars to capture solar energy. Think of it like a giant solar panel around the sun. These could be solid shells or a swarm of satellites, all soaking up the sun's energy and converting it into power. So here's the exciting part. In June 2024, researchers looked at data from big space surveys like the Wide Field Infrared Survey Explorer and Gaia. They found 7 stars within 1,000 light-years of Earth, giving off strange infrared signals. This got people wondering, could these be Dyson spheres? But hold on a minute. Science always has to consider other possibilities. It turns out at least 3 of these stars might be surrounded by something called hot dust-obscured galaxies, or hot dogs. These galaxies have thick dust clouds that can also give off lots of infrared radiation, which might explain these weird signals without needing to think about aliens.
It's possible that these are the elusive Dyson spheres?
So I think it's very unlikely, but I'm open.
Astrophysicist Jana Levin and other experts are skeptical about the alien idea. They say it's important to rule out all other explanations first. Even though we're all excited about the idea of finding extraterrestrial intelligence, the evidence so far doesn't prove anything. Astronomical observations can be tricky. What looks like alien technology could be something more ordinary. Advanced tools like the James Webb Space Telescope will help us dig deeper into these signals. The search for alien life goes on, but for now, we need to keep investigating and exploring all possibilities. The idea of alien megastructures is super cool and gives us a way to think about super advanced civilizations. While the current evidence doesn't confirm Dyson spheres, it shows how complex and exciting space research is. Could these unusual signals eventually point to advanced alien life? Only time and more research will tell. Number 2. Micronova. Have you ever heard of a micronova? Recently, astronomers identified a new type of stellar explosion called a micronova. Micronovae can burn through vast amounts of stellar material quickly. Imagine a stellar explosion that acts like a microfusion bomb, where hydrogen fuses into helium with about 1/1,000,000th the strength of a typical nova explosion. So, how do these micronovae happen? They occur when a white dwarf siphons hydrogen from a companion star. The material piles up and ignites in localized fusion reactions at the star's magnetic poles. These concentrated explosions are fascinating because they show us a new way that white dwarfs interact with their companion stars. The discovery of micronovae was made using data from NASA's Transiting Exoplanet Survey satellite, or TESS, and confirmed by the European Southern Observatory's Very Large Telescope. The discovery of micronovae offers a fresh perspective on stellar explosions and underscores the ever-evolving nature of our universe. These discoveries challenge our old theories and pave the way for new research into the mysteries of the cosmos. Number 3. Detection of water vapor on exoplanets. Imagine finding water vapor on planets orbiting stars far beyond our solar system. Astronomers have detected water vapor in the atmospheres of several exoplanets. This is thrilling because it means these far-off worlds might have conditions that could support life. Let's look at a couple of exciting examples. First, there's K218b. Using data from the Hubble Space Telescope, researchers found water vapor in the atmosphere of K218b, an exoplanet about twice the size of Earth. It orbits in the habitable zone of its red dwarf star, located about 110 light-years away. If confirmed, K218b would be the only exoplanet known to have both water vapor in its atmosphere and temperatures that could support liquid water on a rocky surface. Next is GJ 9827d. Observations with Hubble showed water vapor in the atmosphere of GJ 9827d, a small exoplanet about twice Earth's diameter, located 97 light-years away. While these discoveries are exciting, we still have many questions about these exoplanets. Are they rocky planets with thick, steamy atmospheres, or are they more like mini-Neptunes with puffy, hydrogen-rich atmospheres containing water vapor? These findings bring us closer to answering the big question: are we alone in the universe? Number 4. Potential biosignatures on Venus. Can life exist on Venus despite its extreme conditions? Recent discoveries hint that it might be possible. Let's dive into what's been found in Venus's atmosphere and what it could mean. Astronomers have spotted possible signs of life, like phosphine and ammonia, in Venus's atmosphere. Back in 2020, telescopes found weak signals of phosphine, a gas linked to life on Earth. However, this discovery is debated, with some suggesting it might be sulfur dioxide instead. More recently, the Green Bank radio telescope detected ammonia. This gas could help neutralize Venus's highly acidic atmosphere, which might allow microbes to survive in the upper cloud layers. But it's still unclear why any potential life forms on Venus would produce these gases. Follow-up observations with space telescopes like SOFIA haven't yet confirmed phosphine for sure. Even if these gases are present, they might come from non-biological sources, meaning they could be created by Venus's harsh environment rather than by life. In short, while the possible signs of life on Venus are intriguing, they're still up for debate. More research and observations are needed to figure out if Venus could support life. Number 5. Galactic cannibalism. Ever wondered if galaxies eat each other? That's what's known as galactic cannibalism, a fascinating cosmic event where a bigger galaxy merges with and swallows a smaller one, changing their shapes and making them mix in dramatic ways. When galaxies collide, their gravity pulls on each other, distorting their shapes and causing all sorts of interesting things to happen. As the smaller galaxy gets gobbled up, it often leaves behind a stellar stream, a line of stars that used to belong to it. This process not only reshapes the galaxies involved, but also helps the larger galaxy grow over time. Recent studies have shed light on this galactic munching, especially with dwarf galaxies around the Milky Way. Take the tiny galaxy Tucana 2, for example. It might be the result of such a merger. Scientists think Tucana 2 might have absorbed a smaller galaxy, creating an extended dark matter halo that now holds distant stars in its gravitational pull. Galactic cannibalism happens more often than you might think and plays a huge role in how galaxies grow and evolve over cosmic time. The Milky Way itself has a long history of these mergers, which have shaped its current look and star patterns. So in short, galactic cannibalism is a mind-blowing phenomenon that shows the incredible forces driving the growth and transformation of galaxies across the cosmos. Number 6. Fast radio bursts, or FRBs. Imagine catching a glimpse of super intense radio waves shooting across the universe. That's what fast radio bursts, or FRBs, are all about. Discovered in 2007, These bursts last only a few milliseconds, but pack as much energy as the sun does over several days. FRBs are known for their incredibly short duration and huge energy release. Some FRBs happen just once, while others keep repeating. Scientists are still figuring out where FRBs come from, with theories suggesting they might be caused by magnetars or supermagnetic neutron stars, neutron star mergers, or even signals from extraterrestrial civilizations.
How are you going to figure out what these things are? The first thing you need to know is, where are they coming from?
Spotting FRBs is tricky because they need special radio telescopes. When these bursts occur, their signals help us learn more about the space they travel through, including the density of interstellar gas. This makes FRBs fascinating and important for understanding how matter is spread out in the universe. Studying FRBs gives astronomers insights into neutron stars and the cosmic web. They're a big mystery, and scientists are eager to crack the code behind them. Some FRBs are linked to known galaxies, but many are still unexplained, leaving researchers guessing about the powerful forces behind these bursts.
If you're a smart theoretician, you'll be able to sit down at your desk and figure out what the heck these babies are.
Number 7. Gravitational waves. Gravitational waves are like ripples in the fabric of space-time. They're caused when massive objects like black holes or neutron stars accelerate and collide. Albert Einstein predicted these waves in 1916 as part of his general theory of relativity. These waves travel at the speed of light and carry information about their origins. By studying these waves, researchers can gain insights into the most violent and energetic phenomena in the universe, helping us understand black holes, neutron stars, and space-time itself. Number 8. Dark matter research. Dark matter is a mysterious and invisible form of matter that's one of the biggest puzzles in astrophysics. It doesn't emit, absorb, or reflect light, so we can only detect it through its gravitational effects on visible matter. Dark matter makes up about 27% of the universe's total mass energy content, while ordinary matter is only about 5%. The idea of dark matter was first suggested in the 1930s by Fritz Zwicky. He noticed that galaxies in clusters were moving faster than could be explained by the visible matter alone, implying there was unseen mass. Since then, research has focused on identifying what dark matter is made of. Leading candidates are weakly interacting massive particles, or WIMPs, and axions. WIMPs are thought to be heavier than protons, while axions are much lighter and might convert to detectable photons in strong magnetic fields. Dark matter research is crucial for understanding the universe, and scientists are continually seeking answers to this cosmic mystery. Number 9. Expansion of the universe. The expansion of the universe is a fundamental concept in modern cosmology. It refers to the increasing distance between parts of the observable universe over time. This expansion started with the Big Bang about 13.8 billion years ago. As the universe expands, light from distant galaxies is redshifted, meaning its wavelength is stretched. This is similar to how waves on an inflating balloon stretch as points on the surface move apart. Observations also show that the universe's expansion is accelerating due to dark energy, a mysterious force counteracting gravity. This acceleration started about 5 billion years ago, indicating that dark energy makes up about 68% of the universe's total energy density. If dark energy continues to dominate, the universe might expand forever, leading to scenarios like the heat death or Big Freeze, where galaxies drift apart and the universe becomes cold and dark. Alternatively, if conditions change, other outcomes like a big crunch or big rip could happen. Number 10. Astrobiological studies on Mars. Astrobiological studies on Mars focus on understanding if there was ever life on the red planet or if there still might be. Researchers look for past habitable environments, search for organic compounds and signs of life, study Earth's extreme environments as Mars-like examples, and work on avoiding contamination of Mars with Earth microbes. Missions like Curiosity have found geological evidence suggesting parts of Mars could have supported microbial life in the past when it was warmer and wetter. This means Mars had liquid water, which is essential for life. Bringing Martian samples to Earth will allow detailed analyses, giving us a better understanding of Mars's potential for life. Number 11. Lunar water ice. The discovery and study of water ice on the Moon are crucial for future human exploration. Researchers focus on understanding where the water ice is, how much there is, and how accessible it is. Evidence of water ice on the Moon has grown over the decades. Missions like Lunar Prospector and Chandrayaan-1 provided significant findings, especially in permanently shadowed regions near the lunar poles. Lunar Prospector detected enhanced hydrogen concentrations, suggesting water ice, while Mini-SAR on Chandrayaan-1 indicated large ice deposits in northern craters. Water ice on the Moon is not in large sheets, but mixed with the lunar soil, often less than 10 centimeters in size. Some water is also found as hydroxyl groups chemically bonded with minerals. The best places to find water ice are the permanently shadowed craters at the poles, where temperatures remain extremely low, allowing ice to persist for billions of years. Water ice on the Moon is vital for future exploration. It can support life and potentially be used as fuel for missions to Mars and beyond. The estimated total mass of lunar water ice could be around 6 trillion kilograms, mostly in the polar regions. Studying lunar water ice is essential for sustainable exploration and opens up new possibilities for human space exploration. Number 12. Planetary defense initiatives. Planetary defense initiatives focus on monitoring, detecting, and potentially mitigating threats from near-Earth objects like asteroids and comets. These efforts aim to protect Earth from impacts that could cause significant damage. Organizations like NASA and the European Space Agency use telescopes to identify and track NNEOs. NASA's Double Asteroid Redirection Test, or DART mission, demonstrated the kinetic impactor technique, which involves colliding a spacecraft with an asteroid to alter its orbit. Other proposed methods include nuclear deflection and gravity tractors, which use gravitational forces to change an asteroid's path gradually. Planetary defense requires global cooperation. In the US, congressional actions have directed NASA and other agencies to prioritize planetary defense. These initiatives ensure Earth is prepared to respond to potential asteroid threats, minimizing the risks of cosmic impacts. Number 13. Neutrino astronomy. Neutrino astronomy involves studying astronomical objects by observing neutrinos, nearly massless and electrically neutral particles produced in high-energy processes like nuclear reactions in stars, supernovae, and cosmic ray interactions. Neutrinos travel vast distances without being absorbed or deflected, making them valuable cosmic messengers. When a neutrino interacts with detector material, it can produce secondary particles, such as muons, which generate detectable light or Cherenkov radiation. Neutrinos come from various astrophysical phenomena, including the Sun, supernovae, and active galactic nuclei. They provide unique information about processes not accessible through traditional electromagnetic observations, revealing details about stellar cores and black hole environments. In summary, neutrino astronomy enhances our ability to observe and understand the universe, especially high-energy processes hidden from conventional telescopes, offering deeper insights into the cosmos. Number 14. The Great Attractor. The Great Attractor is a massive gravitational anomaly located about 150 to 250 million light-years away within a giant cluster of galaxies called the Laniakea supercluster. This supercluster includes our Milky Way galaxy and around 100,000 other galaxies. The Great Attractor has a huge mass, roughly 10 circumflex 16 times that of our Sun. Discovered in the 1970s, scientists noticed that galaxies are being pulled toward this area. Its gravitational pull is so strong that it affects the movement of galaxies over vast distances. This suggests that the Great Attractor is made up of several galaxy clusters, including the Norma cluster and the even bigger Shapley supercluster. The Great Attractor is a massive region pulling galaxies toward it within the Laniakea supercluster, showing just how complex and dynamic our universe is. Number 15. Artificial intelligence in astronomy. Artificial intelligence, or AI, is changing how we study the stars by helping us analyze data, automate processes, and make discoveries. Modern telescopes and space missions collect huge amounts of data, often measured in petabytes. AI, especially machine learning, helps us sort through this data to find patterns and anomalies that humans might miss. AI is revolutionizing how we detect and classify celestial objects. Machine learning models can automatically analyze large datasets and accurately identify galaxies, stars, and events like supernovae. This speeds up research and improves how we classify objects. AI encourages global collaboration among astronomers, making it easier to share data and analyze it together. This leads to groundbreaking discoveries and advancements in research. However, as AI becomes more common in astronomy, we need to address ethical issues like data bias and decision-making transparency. Handling these concerns ensures that we use AI responsibly in our research. Number 16. Hot Jupiters. Hot Jupiters are gas giant exoplanets similar in size to Jupiter, but orbiting extremely close to their host stars, with orbits shorter than 10 days. Their proximity to their stars makes them easier to detect because they cause noticeable wobbles in the motion of their stars. Hot Jupiters have tight orbits, often closer to their stars than Mercury is to our Sun, and they have scorching surface temperatures ranging from 1400 degrees Fahrenheit to 5000 degrees Fahrenheit. Many of these planets are tidally locked, meaning one side always faces the star, creating huge temperature differences between the day and night sides. Due to intense tidal forces, they are unlikely to have stable moons. Observations suggest that hot Jupiters likely contain water vapor and carbon monoxide in their atmospheres. Future observations with advanced telescopes like the James Webb Space Telescope will give us deeper insights into these extreme exoplanets. Number 17. Technosignatures. Technosignatures are indicators of advanced extraterrestrial civilizations, detectable through their technological activities. These signatures can include radio signals, laser emissions, atmospheric pollution like nitrogen dioxide or chlorofluorocarbons, city lights on exoplanets, large-scale surface structures, orbiting satellites, and megastructures that cause infrared excesses or gravitational effects. NASA supports the scientific search for technosignatures as part of the larger quest to find extraterrestrial life. Even negative results are valuable, as they help us set upper limits on the prevalence of certain types of extraterrestrial technology. As we refine our search methods and technologies, the pursuit of technosignatures continues to push the boundaries of our understanding of the universe and the potential for life beyond our planet. Number 18. The Kardashev Scale. Imagine a scale that measures a civilization's technological prowess based on its ability to harness energy. That's what the Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, does. At the most basic level, we have what's called a Type Y civilization. This kind of society can utilize all the energy available on its home planet. Picture harnessing every bit of energy from the wind, sun, and even the heat inside the Earth. A Type I civilization not only makes the most of its planet's resources, but also manages natural disasters and climate with incredible efficiency. Moving up, we get to a Type II civilization, which is a whole new ballgame. This civilization would be able to tap into the total energy output of its star. Think of a futuristic concept like a Dyson sphere, a gigantic structure encircling a star to capture its energy. Then there's the Type III civilization, which operates on an even grander scale. Imagine a civilization that controls energy across an entire galaxy using the power of all the stars within it. This level of advancement is so far beyond our current technology that it's almost beyond imagination. Humanity is currently somewhere around 0.72 on this scale. We're making impressive strides, but we're still a long way from harnessing all the energy our planet offers, let alone reaching the full potential of a Type I civilization. The Kardashev scale gives us a framework to think about where we stand and what the future might hold. It also helps us ponder the possibilities of advanced extraterrestrial civilizations out there, potentially operating on scales we can only dream of. Number 19. TESS. In April 2018, NASA launched the Transiting Exoplanet Survey Satellite, or TESS, to hunt for new exoplanets. TESS uses the transit method, which involves watching stars to see if any planets pass in front of them. Its main goal is to scan the entire sky and find exoplanets orbiting stars that are relatively close, less than 300 light-years away. The mission hopes to discover around 3,000 new exoplanet candidates, including roughly 500 that are Earth-sized or larger. What makes TESS special is its wide field of view. Unlike its predecessor, the Kepler mission, TESS can observe a much larger area of the sky all at once. It has 4 wide-angle cameras that let it monitor millions of stars simultaneously. TESS is a huge leap forward in our quest to understand planets beyond our solar system. Number 20. The Gaia mission. On December 19, 2013, the European Space Agency, or ESA, launched the Gaia mission with the goal of creating the most detailed 3D map of our Milky Way galaxy. Gaia orbits around Lagrange Point 2, which is about 1.5 million kilometers from Earth. This position helps it avoid the blurriness caused by Earth's atmosphere and capture incredibly accurate data. Gaia's main mission is to map the positions and movements of about 1 billion stars, about 1% of the stars in the Milky Way. It's equipped with 2 telescopes and the largest digital camera ever sent into space with nearly 1 billion pixels. Since Gaia started its mission in July 2014, it has been sending back massive amounts of data, between 20 and 100 gigabytes every day. This data has led to incredible discoveries, such as detecting star quakes and creating the largest chemical map of the Milky Way. This map provides detailed information about the ages, masses, and compositions of stars. Gaia is set to continue its mission until 2025, with its final data release planned for 2030. The information Gaia provides will give us a deeper understanding of how our galaxy formed and evolved. Its detailed map will be an essential tool for astronomers, helping us learn more about the universe and our place within it. Thanks for watching. What do you think about the possibility of alien megastructures? Let us know in the comments below. Until next time, keep looking up at the stars and wondering about the mysteries they hold.